All right, there we go. All right, so let me go ahead and share my screen. Okay, so yeah, so we're covering the Nreal Light. So one thing that came out just recently, though, is Nreal announced just earlier today a new headset, the Nreal Air. And actually, one second, let's look at this. You can see the numbers on my screen. Let me see if I can.
We're not seeing the screen share right now.
Are you not seeing that? Okay, one second. All right. Can you see it now?
Yes.
Yes.
All right, excellent. Thank you. All right. So we planned this presentation on Nreal Light, but a week ago, Nreal announced $100 million in new funding, as well as they're going to be announcing a new headset. And today, the information about that new headset came out. I was a little, surprised about what some of the specs are, but I think they've decided to sort of target a very specific portion of the market. So the new headset is now a replacement for the existing Nreal Light, but it's targeted more towards people who are into video streaming. And so they have a couple of modes for it: a 0 DOF mode, where basically it's locked to your face, and a 3 DOF mode as well. I've seen from at least from some media reports, not all of them mentioned that. So I'm hoping that's the case, because obviously that allows a bit more functionality. They are increasing the improving the display and increasing it to a 90 hertz refresh rate and a very high PPD number. They are slightly cutting the aspect, the size of the display to, so only encompasses about 46 degree of view, versus the Nreal Light is about 52 degrees. It's slightly lighter, 77 grams, and there'll be a new SDK coming out for it. They sent it about a month. And they're going to be releasing this in November in Japan, South Korea, and China. They haven't given any pricing for it yet, but it's supposed to be significantly cheaper than the existing headsets, which, depending on your market, range from $600 to about $1,000. So the Nreal Light, so this is a basically a display that connects to a smartphone. Some of the higher end models that are available on the Android side. So it's a slightly different form factor than you see with like a HoloLens, where it's all in one, or obviously VR headsets, which are all in one, or tethered to PC. This is sort of more akin to the tethered systems, but because it's in AR, they're tethering directly to a phone to provide the compute for that. In terms of the specs, it has a 52 degree diagonal field of view, and it's a slightly wider field of view. And I have some diagrams on that a little bit, and then what you see on the HoloLens, which actually has its plus and minuses, because it also means it's narrower vertically. The resolution is 1080p, and actually it seems pretty sharp when you use it. And in fact, in the color, actually I'll get into it, but the color actually seems a bit sharper than the HoloLens too as well. It's 106 grams. Fortunately, most of that weight is on the front, so you do feel it on your nose, but it's not something I necessarily would say is comfortable to wear long term, but for a few minutes at a time, it works well. And it may be getting the how you position in terms of how long you can stand it to wear it. There are two tracking cameras on either side of the glasses, and one RGB camera located in the center. And there actually is a little white light to the side of the RGB camera that indicates when recording is going on. So if you're trying to know if somebody's recording your area, that's one thing to look for. There's also an ambient light sensor. Although I haven't seen any direct access to that in the SDK. To be curious to see if that's something that's haven't enabled, or if they're only using it internally. There's a proximity sensor that basically can tell if you have the glasses on or not, mostly for battery saving purposes. The There are stereo speakers on the arms, as well as dual microphones. And it uses a USB-C connection that works with some of the higher end smartphones. In fact, right now I'm using the compute pack, which you can see back here, that came with it for testing, because I've had to order a new phone to actually be compatible with it. You can order the dev kits right now for about $10.80, but the consumer prices, this is based on exchange rates, so it can vary, are between $600 and $930. And this is actually the only consumer AR headset that's available that I know of. So right now you can purchase it in South Korea, Japan, Germany, and Spain. And supposedly it's supposed to be coming to the US in Q4 2021. So probably on T-Mobile, but I haven't seen any hard information on that yet. By the way, if you have any questions or comments with that, please feel free to interject.
So I'm curious, did you got for yourself, did you get it through somebody you know overseas?
No, I actually ordered directly from Nreal. They made orders from the US available in June.
Oh, okay, great.
Yeah.
Because when you go to the website, it's not clear. So that's good to know. Thank you.
Yeah, I did have to do a registrations with customs to be able to get it through.
And how much was the customs? Did you have to pay a lot to get it through?
I don't recall. I think it's about $40.
Oh, okay.
It wasn't bad.
Okay, thank you.
Let's see. This is sort of a video from Nreal showcasing spatial actually on the platform, but it gives you an idea of how some interactions work with it. So I'm going to go ahead and play that. Actually, let me make sure the audio sharing is working, since we frequently have that issue. All right, it's a short video, but it gives you ideas how some interactions work. So the headsets are 6-DoF tracked. The developer kit comes with a small puck that you can use. That's a 3-DoF, has a touchpad, and you can click on it. But this is really only for developers. Normally, you'd be using your phone, and it uses the iMune accelerometer on the phone to actually estimate orientation. I found I've had to frequently reset the if you used Google Daydream a bit, or even Oculus Go, you're probably familiar with that process, but you have to frequently recalibrate the controller to make sure it's matching up. But you can also interact with the phone, and you can actually create custom interfaces on the phone to offer more buttons and controls. It's a quick history of Nreal. So it's a relatively recent company. It was formed in January 2017 by a pair of founders, one of which had worked previously for Magic Leap, and they sued them in 2019 for that. That was dismissed, though. They unveiled the first Nreal Light headset in January 2019, and they started rolling out to dev kits and launched their SDK in July of that year. And about a year ago, they actually started launching it commercially with carriers, first in South Korea with LG U+, and then with Japan, and then in the last few months with in Germany and Spain. And of course, they just announced their new headset. Oh, this is a quick snap through the tracking cameras. You can get, if you hook up directly to a PC, you can use some tools to actually capture some of the camera data directly off of it. So you can sort of get an idea of the field of view the cameras are using. for tracking, and they're just in the infrared space. So. See, Carl Gutag, if you're all familiar with, but he actually does a lot of analysis of AR headsets, and he did some really nice breakdowns of the Nreal headset. So it uses what they call bird bath optics. There's a diagram a little farther down here. So there's a display above the visual part of the glasses that's reflected through a 45-degree angle piece of glass, and then back through the lens to the eye. And actually, it works pretty well. There's a few other companies that are using some similar setups, and it gives some really nice amount of light that passes through, and it doesn't distort the color very much, which is a nice feature versus some of the other waveguide type approaches. There are some limitations to it, though. You tend to end up with a pretty large amount of hardware above the eye, and as you can see, much of the eye is blocked by the display systems, and of course the camera. And this is a picture he's taken. There's a polarizer that keeps some of the light from exiting out to other viewers can see, but he's going to be doing this side. So you can see how much of the light actually is being passed into the user. So he also did a comparison to the Hollins 2. Let's see. Basically breaking down some amount of detail you can get within this center part of the images versus the edge. But Carl found it that tend to have a much better image clarity than he found in Hollins 2, and I've seen the same from my use of it. Back in February, Nreal released some information about some usage of the Nreal Light. They were seeing users averaging about 49 minutes per day on the headset. And the top 20% users were spending out 120 minutes per day at that time. And the time where, I was sort of wondering where that was coming from, and speculating it's probably streaming content. And they just confirmed that today when they're unveiling the Nreal Air device, saying about 78% of the time users were using it for streaming content, which is why they've decided to focus Nreal Air on that.
Interesting.
At the time back in February, they had about there were two numbers mentioned here: 700 to 3,000 developers. I think so. So I'm not sure what that breakdown is, but yeah. And some of that's in the VentureBeat article, in other words. And I'll share the presentation on the Meetup site afterwards, and also on our Discord channel later. There's a couple different modes of use. So they actually have, they also have what they call a zero DOF mode, which is basically when it's locked to your to your eyes. That's what in the developer kit, that's what sort of comes up by default. And then you actually launch your experience to actually go into an actual 6 DOF or 3 DOF experience. Yeah, zero DOF for me actually causes quite a bit of discomfort pretty quickly. So I definitely not encourage people to take that approach and design their experiences. They also have a 3 DOF mode, VR mode, because you can basically clip on a cover over the lenses. But there's quite a bit of light leakage coming in through the bottom. So it's not really the optimal VR headset, although it can operate in that manner. The other problem with their design for VR is that it covers over the tracking cameras. So you're not really able to take advantage of any 6 DOF content. But the core experience they have for Nreal is called Nebula, and they just released their Nebula 2 app. This is basically what you do when you put this on a smartphone. This is what is used as a launcher, as well as to access web content and some other integrate other apps into the experience. I have a short video of. It also allows you to pull in on some carriers that they've enabled this, pull in other 2D native Android apps and integrate them in your field of view, like they were showing TikTok on the side there. And supposedly there is actually WebXR support, because this is basically a Chrome integration within the app. But I've not had a chance to test it out myself yet. So once I receive my my test phone, I'll do some experimenting with it, because unfortunately Nebula isn't available on the for the compute device.
The resolution looks, not just the resolution, but the amount of light, it feels like it's very opaque. It's pretty amazing. Does it look that good through the glasses?
It does indoors. So yeah, I've taken outside, and at that point, yeah, it gets washed out pretty easily, which is part of the reason when we were talking about the snap spectacles, I was asking Sasha about her experience with that. But as long as I'm in my apartment, it works fantastic in terms of amount of light.
Cool.
In terms of field of view, this is a comparison of several different VR headsets and AR headsets. The VR ones, of course, ones on the outside of it, generally have a much wider field of view. And
is it a spectacle there? Just try to
actually, I created this doc before spectacles came out. I think the spectacles is only about 26 degrees, so it actually it'd be right here in the middle. Yeah,
they kind of small, but it is
right. So if we zoom in on this, get a rough comparison between the different headsets. So the Nreal is slightly wider than what you see on the Magic Leap or HoloLens 2, but narrower. And it's a challenge either way you do it. I mean, one of the big problems you have with AR headsets is being aware of the items that have been placed in the space. And since you have such a limited field of view, and your peripheral, you still actually see the peripheral vision, it's very easy to lose track of those items that are supposed to be there. The width helps, but having such a narrow vertical field of view is still very problematic. So I can't. There are a number of new glasses, and actually we have some in the news, as well as some other ones out there, but announced that actually have much more dramatic, a wide field of views that I really look forward to getting my hands on, see how those feel. In terms of the devices it currently supports, it's pretty much the latest crop of Android phones. So all the last couple of generations of Samsung Galaxy devices, as well as Oppo phones, Xperia. This was also announced back in February as their enterprise edition. It's still a tethered device, but they've tried to target some of the challenges you have with the existing Nreal Light. So there's actually eye cups around the edge, which help block some of the light that leaks in. And the halo design theory should be more comfortable. This actually hasn't been released yet. They've just actually announced it and released a video and some pictures, but I'm not sure what their current plans are, but I guess we'll have to keep an eye out for it. There are also some accessories that have been announced. So there's a company actually located here in the Bay Area called Finch, which produces controllers for VR devices, and they actually released a Ring controller recently and announced compatibility with Nreal as well. With just the Ring, you can use it as a 3DoF controller using an accelerometer, or if you add in the armband, you can actually get a 6DoF experience as well. But one of the nice things about it would actually provide some haptic feedback and a little bit more surety. One of the problems you have with a controller's experience is actually knowing if you actually is trying to trigger a button press or do something else like that. So in theory, having this versus just a completely hands-free approach might be more comfortable.
I'm sorry, what's the armband?
Yeah, that's provide tracking with the controller. So for 6DoF.
So you have to use both?
You don't have to. You can just use the Ring by itself and as a 3DoF controller. But with the armband, you can actually get 6DoF. Actually, I can play a short video for this as well. Let's see. Yes, I think there's a lot of potential in AR for these haptic rings. So I'd like to get my hands on this and literally and have a chance to try it out.
I found one on one of those I can't like crowdsourcing sites.
Mm-hmm.
So I haven't actually tried it yet. I've had it for several months. I haven't had time to even try it. But yeah, I'm excited to do it also. Let us know if you do.
Okay. Yep. So in the developer kits, this is what comes. So it's there's a clip. This is the compute unit and in the controller. And we'll say this is actually probably one of the worst designs for a controller I've seen. Just especially for one that actually is supposed to have an orientation for 3DoF, because there's as a circle, it's very easy to actually grab it with in the wrong direction, because there is a front and a back with only there's a small light and a slightly raised area at one point. So if you ever design a headset with a controller that has to be 3DoF, I would suggest not going in this direction. The Daydream or even with the Oculus Go controllers, Oculus Go especially, were much better designs. They have several nose clips depending on just for the size of your nose to make it more comfortable the way it sits. They also include a couple of lenses that you can take to your optometrist to have them ground for your prescription. So if you want to trade those out to make it work if you need corrective vision. That's one challenge with this versus like the HoloLens 2 and some other devices, that you can't really wear them with glasses comfortably. So it's nice of them to offer this, but it does make it harder to share it with somebody else if you need to take that route. Beyond that, just standard charging and data cable, but it's a nice case for it as well. The developer kit is a Snapdragon 845, 64 gigabytes of space, which is pretty decent for testing. And just have a nice magnetic attachment for the controller too. I've only accidentally dropped it once trying to put it on the its holster. There's a light that indicates when it's live, and you can turn the power on or off for the controller. But the base computing unit actually keeps the controller charged. And I really haven't had to really think about charging it because I connected it back to the computer to resync up with updates and all that, and I barely drop below 90% on either of the devices. There's a trackpad, and it's basically designed for mimicking what you might do on a phone, and as well as you can depress it for clicking. And generally, if you press near the bottom, it's a for recalibrating the 3DOF controller. So the way that Nreal SDK works, this is a little different from what you see in some other devices like a Quest, something like that, because this actually sits on top of the OS, and it's actually integrated in direct. They show it separate from Unity. This basically integrates directly inside of Unity, so it's not really a separate layer here in terms of the actual function. It's all part of what you have in your project. So you have your base unit, Android, Windows. When on a Quest and some other ones that are all ones, they actually generally have a number of services running in the background for managing the tracking and the menu system and everything else like that. But because this is all integrated within the application, that's not really the case. I'm curious to see with Nebula, if once you launch a application through that, if it goes into like a background service mode, then that comes back after you exit. But I'll have to check on that later on. Yeah, so we can go into how you actually work with the SDK. So if you have, it's basically a standard Unity project. I'm gonna go ahead and load up. They have an emulator they can use for testing some simple interactions such as image tracking and plane interactions. But it's mostly just allow you to more easily set up your interaction. Let's see. So basically, it replicates the form of a nice living room, and you can use standard keyboard controls to move around the space to simulate. So, for instance, this is the phone as the user moves away. This is the track image that it'd be looking for, and as the user moves away. Oh, actually, you probably can't see my desk. Maybe it's the other monitor. I apologize. Can you see it now?
Yes, yeah, we can see
Okay.
that. Oh, I didn't know you have a Unity.
So yeah, sorry, I had too many different windows open. So yes, so basically you use keyboard controls to move around the scene, and as the user, this is basically simulating the user moving around the environment as they see it. The object can appear. I'm not sure it could be useful for testing some interactions, but generally you end up needing to do most of your testing on the device. Getting started, basically you set up Unity with standard Android development added in, install the Nreal SDK that you can download directly from the Nreal website. So if you go to the developer section, you can download directly from them. They have a number of suggestions in their developer's guide about how to set up. So you basically, would you want to go through all those and make sure you're following it? And then there's, you can open one of the demo scenes they have in the project, just add to the build settings and deploy like you would any sort of Android app. So it's a pretty simple setup. The core features they offer, there's 6-stop head tracking. So that usually once you start experience takes about 2 to 3 seconds to kick in. There's also the 3-dot controller or phone. They do have plane tracking. So basically looking for planes, both horizontal or vertical. it's not as fast as some other environments as detecting them, and there's some limitations to that, but I'll get into that a little bit later. They have an image tracking feature. Hand tracking was added about a year ago using Clay Air. They licensed their SDK integrate in. It works okay, but it's because of the tracking cameras have a pretty narrow field of view. It's can be, you have to keep your hands up a lot more higher than might be comfortable for long-term use. There's some interactions you can do with the controller. You also, if you're using for an actual consumer deployment, if you're on the phone, you actually customize what's on the screen, and they provide some interfaces for doing that. But it's basically running a standard Android app, so you can target a lot more of that if you want. There's the emulator we talked about earlier. They also allow access to the RGB camera front to capture images or video, and their SDK makes it pretty easy to stream video out as well. So in terms of the plane tracking, this is basically their SDK provides a number of planes that have been identified and their vertices. It'll basically dynamically give those to you as updates. And you can use the plane visualizer they provide to render those out, or you can obviously create your own, depending on what you want to do. So I can show you a quick video of my experience with that. So I'm looking around and it's starting to get tracking information. You'll see a tracking grid appear now as it recognizes the planes. And basically I'm clicking and pointing at different locations for it to add objects into the scene. You can see that it's not as stable as some other headsets. You can see there's a bit of a bob there as I got closer to the surface. And it's something you want to try to accommodate when you're designing your applications. Here is detecting a vertical plane. Okay. Yeah, one challenge have with the way the planes operate in our SDK versus some other ones like ARKit or AirCore is that it tends to join any planes that are at the same level with each other. So even bridge like even a meter or two across. And I'm not sure if it may go farther than that. I haven't tested it too far, but it does make it a little hard to actually get closer confirmation to the actual geometry of the room. Hopefully that's something that they could improve in the future.
A quick question on that.
Mm-hmm.
That instability in the tracking and the finding of surfaces, do you think
Right.
that's something that's going to be improved when you switch to the phone instead of the compute unit?
Probably not, but because you could see it actually even in their marketing videos earlier, they had some where they had the camera locked, so everything was really stable. But other cases where they actually did it with a moving view, it had the same issues. But those were actually taken a few months ago at least, so it's possible that could improve in the future. One thing too, they don't actually offer access to the point cloud data like you can get on some other headsets.
Okay.
It'd be nice to actually be able to get that as well. I was hoping I'll get that and sort of dig in and see if I could actually do my own geometry estimation to sort of deal with this. But yeah, it's definitely an area of improvement for the headset and something you'll want to like take into account when you're designing stuff for it. See, another feature they have is image tracking. So this allows up to 10 images that you load into a image database, and they score them based on the features in the image that identifies. So for instance, this is a database they provided was canned, where they have some number of different images that they've pre-selected, and so they rate it based on the quality of the image. Unfortunately, I have not had much good luck with the image tracking. Can do a quick demo of that here though. But let's switch the microphone. All right, can you hear me?
Yeah.
All right, terrific. Okay. All right, and all right, now launch. Oh, actually, I realized I need to, before I do that, I'll need to put this on the headset. So 1 second. So I'm gonna go ahead and load one of their demos. This is their tracking image demo. And basically the process for building for this is you basically you have your standard camera rig like you would with a lot of different ones in for like the Quest. You know, it has the standard positions for left and right camera as well as the center anchor. There's a input module that you can use for accessing the input, but actually this basically represents it in the scene. So you can access it programmatically from your own script easily, and you can choose where you want the source to come from. So if you want, you're using hands or controller, you can actually easily switch between those modes. And then in the example, it's using the tracking image database I showed a while ago to try to look for those images. So maybe build this. Apologies, I realized I'd changed out what I had installed on the device shortly before the meeting. Didn't reinstall this one. But basically, once you attach the device, you use ADB or you actually be built directly to it. So let's check and see what's connected. All right, so you can see the device now. So it's finishing up the build currently. Yeah, watch product never builds. So,
So these APKs and stuff that you're using, it's all Unity?
they are. Now, actually, I just realized I didn't put the video streamer component on here. I need to add that in. Create a prefab for that. This is good, but it's actually not missing by default. So, actually, let me go. I'll save this and build it, and then we'll come back to it in just a moment, so that you don't have to wait on it. All right. Okay, so this is a video I recorded earlier of the hand tracking. So it basically reports that the estimation of the joints as well as the state of the hand. So if it has a grab motion, open or pointing. This is using the point to actually, start a drawing process. It's alternative visualization of hands.
So this thing does not have a depth camera, is that right?
It does. So it has two tracking cameras on the side. It's using estimated depth, but
they're optical. It's not using like time of flight or anything.
Right. And I believe actually, I suspect at least that the hand tracking is being done just with the RGB camera, not with. Although actually it is three-dimensional, so it may actually be using two cameras. But obviously, you can see it's not very stable. You definitely want to try to average it out. And I would probably suggest even not showing this up, maybe like fingertips like that as well, because you don't want to confuse the user with some of the mess that's showing. But just show sort of key interaction points, like you move your hand close to an object or something like that, and have the object respond to it, rather than showing the raw joint data.
So no virtual keyboard.
Yeah, it's a challenge. But obviously, since you're using a phone, you can actually use the phone keyboard to type something in, which would probably be a better solution.
I keep forgetting your AR, right? So you can actually use a real keyboard.
Yeah, exactly. This example of using the image capture. So they actually make it really simple. So this is the basic amount of script you need for capturing and displaying it. They're using a Unity raw image control module. It's in their private standard UI set. And you basically just get a texture from their RGB cam texture function, assign it to your raw image, and then just call play to actually have it update the texture. And that's all you have to do. In this case, basically, I'm clicking the button. It's basically taking a photo directly from the scene and placing it on a canvas in free space.
Whoa, you can look at your fridge in front of your fridge.
Yeah, but it's actually a nice way to take photos. Yeah, I look forward to being able to actually, especially as these headsets improve, I mean, actually just taking a photo like that and actually have it show up right in front of you was really, really nice.
It's a lot faster than how HoloLens 2 were like, oh, take photo, tell it to take photo, and then like takes a bit there. That was instantaneous. So
right. Yeah, and it's actually a lot easier process than implementing than the HoloLens 2. I'm not sure why they made it difficult, but this shouldn't be any more difficult than this. Yeah, also you can do video capture and sharing. They provided in the demo, so they provided a built-in source and a sample for that. I extended it slightly. Let me see it. So I just rebuilt this again. So let's see if actually that finished now. Oops. Good. All right, so install that to the device. So let's go ahead and do video streaming. This is using their video capture API, and basically you can stream that to the desktop just using some standard.
Hey, Michael.
Tool. Yeah.
Is it possible to step through code in Android mode?
No, not in Android. If you actually, with ADB, you could actually have it output stuff to the debug log, and you could remote either through Wi-Fi to the device, or just get that log afterwards. But
So how do you, if you need to step through the code when it's in Android, how do you do that?
Yeah, you basically want to have it log and just write out. You can't really step through at that point. So that's definitely something. The HoloLens actually has a nice remoting feature you can use that lets you interactively debug stuff. But unfortunately, it's not something that's available here. Although I was really intrigued by our meeting last week, where we were talking about render streaming, and it might be something you could actually adapt to this device as well. But obviously, it hasn't been done yet. So
how do you if you need to step through the code and make sure that everything, all the parameters are right, and you want to inspect all the arguments to functions, how do you do that when you're developing for like Quest and Android devices?
Well, most with Quest actually you can hook it up and either use AirLink to test with from the desktop, or so that is much simpler.
So it's possible to step through code when you're connected to a Quest?
Yeah, so especially if you use AirLink, you can actually, using regular Oculus SDK, you can, let me start. Should be hopefully starting streaming. Streaming. Let's see. All right. Well, unfortunately, the VLC, the media player is not receiving it. Let me stream. Oh, I didn't. Hold on. Let me check the checkbox. There we go. All right. So now it's actually, this should be seeing my. If it would help, I took off the cut. I was like, why am I not seeing anything? I was in VR mode. All right. Okay. So now you should be seeing what I'm seeing through the headset. And I'm going to go ahead and pull up this tracking image. And so you see there's it's recognized it now and position. Unfortunately, it's about 6 inches behind the actual image position. The tracking isn't that great. So, but it has recognized this image.
Yeah, we're just seeing the image full screen. We're not actually seeing your view anymore.
Oh, really? Oh, yes. Of course that's the case. All right, let me do this.
There we go.
I'll put the image on a different monitor. That way we can both look at it.
So much easier to manage it on another monitor. That's why I always use OBS as virtual camera.
Okay, so now you should be able to see that the image. Yeah.
There you go.
Yes. Yeah, one thing, even though I can see the world with this, yeah, it is. Even using it with monitors is somewhat problematic because it's so bright in the headset. It tends to wash out the monitors and see behind it. All right, just stop the stream. And this is actually how you go about implementing this streaming. You basically you can use VLC, create this SDB files, configuration files to receive the video stream. And all you need to do in terms of modifying the capture example is change the destination from a file to basically IP address of your computer and the port you're using. So some other people suggested some other changes, which I did try out as well. So I'm not sure if they're necessary, but they work for me. And if you ever do want to introduce it, it's on the community forum. Somebody actually posted all the directions about it. That's where I learned this from. There's also been work for MRTK integration. So you can actually download from this GitHub repository. Somebody's added a profile for supporting Nreal Light in it. And this is the video I took actually using that. It says using the hand tracking. So it allows you to easily, if you're porting something from MRTK from another platform, to very easily pull it in and start working with it. And you see the hand tracking isn't quite as good as it might be in some other platforms, but it is functional. These are some optimization tips that Nreal provided for it. And they're says you not go lower than 45 frames. It's a little different from VR in the sense that you're actually, people see the real world as well. So they're not as affected as much by the frame rate as you might be with a regular VR headset, but you still want to make sure things are matching up well. It's just also avoiding having more than 100,000 triangles. A lot of this comes down to the performance of the actual Android devices for trying this, but generally pretty good heuristics to use for when you're trying to decide how you want to optimize. your design solutions for it, which says you probably want to use bright, vivid, contrasting colors. Blacks in AR basically are invisible. So at least at this point, at some point we'll probably have headsets that actually have blacks represented as an occlusion layer, but right now it's a great way to make things invisible, which it can actually be useful if you actually want to hide things, create like a window effect or something like that. You also want to keep your objects moving. It's to make up for some of the tracking issues. So for instance, actually I did make on this slide, there's a example of a scene I made trying to compensate for some of the tracking. So when we start up, it should start placing items once it recognizes the plane. I guess so. So if you keep the objects moving, you don't really notice the tracking issues at all. So it makes it start feeling a lot more lifelike. And I basically had it randomly cycling through spawning different objects. There's a flying one I was waiting to come up. That's why I ended up with like 20 of these because they decided not to spawn that for a while. There we go. So the flying one, as you can get a little closer to it, it seems like when long stuff is moving, that's really stable. But
does it have a built-in occluder?
It doesn't. You could use one of the planes to estimate occlusion, but I say that planes do sometimes extend beyond what you'd want. So you could actually use the planes to actually block types of items. But in theory, you also, if you're wanting to actually have better hand interactions, you could actually use the hand model as an occluder for other objects too, just like a depth occluder. So you could actually block out items. Also, I would generally adjust because of the way the trade-off controller works, that you probably want to not use it so much for pointing, because I frequently, about every minute or so, had to recalibrate it. So there's a lot of drift on the controller. Hope it may be better on the phones. I'll see. So I would either use it just as a simple button or as a trackpad for interacting with environments rather than pointing, and maybe just use the gaze pointing as a better way of selecting items. You want to keep your model small, probably less than 0.5 meter, just to prevent perceived clipping. Like if you have a giant terrain or something like that, you're going to notice those edges as you move around it. But if you actually have objects smaller, like I showed, like the little characters moving around, you tend to actually not notice that they're actually being clipped off as much as you look around the scene. I mentioned earlier, you probably want to avoid showing the hand models directly. Just add proximity indicators that you move close to object to grab it, rather than showing it. Because I tend to actually try to stay away from stuff that might be breaking immersion when you're playing things. Another thing you want to do is if you don't see something in AR, especially since they don't show up in your peripheral vision, they don't really exist for the user. So you'll want to add some visual and audio breadcrumbs to them to let people know that they're there, especially when it's really important for them to know. So for instance, like the characters I added audio sounds to them, so you could actually hear the bee flying around this area. You could hear the different ones moving around, so you could know where they were relative to the world. Somebody could also use like a particle effect if something's off the side, sort of like might lead them back towards to look at that item, or even just some sort of arrow or some other indicator.
Off-screen indicator.
Yep, exactly.
Yeah.
Also, remember audio. So audio, as we were talking earlier with experiences for the blind, this is basically a spatial computing device, and you could actually, audio gives you so much of our information about the world. So you actually could encode stuff even non-visually and actually allow you to move around the space and interact with things in a purely audio perspective. So I think there's a lot that can be done to experiment and explore that approach. Right now, if you're trying to avoid some of the clipping, you can also fade objects as they get closer to the edge of it. That can be done either like a simple mask, or you can use some sort of shader, either like a stipple or one has like fading.
Is stipple like dithering?
Yeah, sorry, dithering. Yeah, that's one that might be a good approach. Yeah, there's some links and resources
if you're trying to find more information about this. So thanks, Al. Actually, I'll go ahead and share this in the chat, but I'll post it up to the group as well. Does anybody have any questions about the Nreal? Well, thanks everyone. As we so as I learn more of it, I'll probably share some more updates with this as I get more into the device and as we get hear more about this as well. But, hope you all enjoyed it. And if you actually have any questions, you can reach out. Don't hesitate to reach out to me as well. So I'm gonna go ahead and stop the recording.